This week, we're going to use LLMs to do command and configuration generation. I used to put this before the code generation, but I think it's probably better now that you've really struggled with prompting an LLM. Because, these commands and configurations, like any error, really messes you up, whereas maybe code has some wiggle room. But the idea is the same, but the actual domain in which you are asking the LLM to produce the content for and execute it is just slightly different. So it's basically an extension. But it depends on what you consider code. I mean, configurations are basically declarative programming languages, and then commands are just imperative, like Unix style ones. So there's a lot of different ways to use an LLM to automate things, and this is just expanding what is there. So I grew up in the day and age where before LLMs, you had to do this when you wanted to learn how to sort of run commands and configure systems. You would have to figure out what you wanted to do, and then you would have to go out and read the documentation. You'd have to say, like, the man pages, for example, is what we used to teach people. Like, go to the man pages to find a Linux command and then figure out how to use it. Or in terms of configuration, you would have to read the spec. Go to the read the docs. And that's like the thing that, I mean, as a student, like me trying to learn it, that's the last thing I wanted to do. It's like, dozens of pages of documentation that are like, I just want to do this one thing. And then what you would do is you try and, from that documentation, craft the syntax. This is before Google, too, so you couldn't just search it and see what someone else produced either. But then you would craft the syntax to perform these operations or to configure these systems. And then you would try it out, and inevitably it wouldn't work. When you execute the command or you try and deploy a configuration, it's not quite exactly correct. You'll get a bunch of errors. And then you debug it. And then in the day and age of Stack Overflow, maybe you would search for someone else. So, but when I was doing this stuff, it was even before search. So it was really painful. And then you would iterate. You do this over and over again. And this is what turns a lot of people away from computer science and computing. It's like, nobody wants to do that. To basically go through an entire afternoon and get one command to work. It's like, that's not enough carrots for most people over an entire day. So that's where we are. But now we are at a point where you just talk to an LLM, say, this is what I want to do. This is how I want the thing done. And then you go figure it out. And hopefully, if you've specified it precisely, it's going to reliably be able to do that. But that's the key. And you saw with your code generation, in 5 minutes, you have to be very precise and very accurate with your words. Otherwise, the LLM is not going to do what you want it to do. Same thing with this. Okay. So here's an interesting chat that I came across. There's this company called PromptOps, where they're trying to do this for operation engineers. So if you're an operations team, and you want to be able to ask questions about your infrastructure, collect information, and you don't want to have to write a script. And this is the idea. It's like, hey, PromptOps, I need the IAM roles for all the EC2 instances that I'm running that are public. I want you to print them in a CSV format and then give me these fields. Sorry, it's small, but the screenshot that I captured was small. So, and then it says, oh, I found a similar question from someone who's already asked this before. And in fact, it was actually created by the person who's asking it, but oh well. And this is it. And I can actually run this thing to get this sort of this script and then this format the way it's done. And so this is it. And so in this case, it's actually producing code, which is this is Python code that interfaces with Photo 3, but you could have done this with the AWS CLI. As a command rather than code in terms of Python. And then it says, okay, run it. So assuming that they clicked run, and then it would give you the exact output. This is the way things are going when it comes to automating ops, which is, it's a pretty heavy duty sort of task for people to do. So one other thing is that this is increasingly being used by adversaries. So Scattered Spider was a bunch of teenagers, and they're like, we don't want to learn PowerShell. We'll just have the LLM generate all the the PowerShell commands that we need to do our malicious activity. So that's what they're doing, and basically to do some of these things. In fact, maybe like we could do someone who does Windows management in this classroom. You could actually do a PowerShell homework assignment to automate that, because I don't even know PowerShell. But if I had an agent that I could say, speak to, then I would never have to learn PowerShell. I could be a Windows administrator without doing anything, without requiring any training. Okay, so I have given you in this week just a tour of a bunch of the commands and configurations that I kind of teach in all of my different classes. So the intro to computer security class, the web and cloud security class, the reverse engineering is kind of like in 2 weeks. But like, I don't have any of these classes as prerequisites for this class. The reason why is because as part of these assignments, if you don't know Kubernetes or Docker or Nginx or any of this stuff, you're going to ask the LLM to explain it to you. So that's basically the idea. So we're going to talk about a lot of commands and a lot of configurations that might be completely foreign to you if you've never taken a security class and you've never done the cloud class or any of these sorts of things. You got to learn it in place and then be able to understand what these commands and configurations are actually doing. Okay, so this is a tour. I'm going to start with simple ones. So if you've ever used Google and you've used it effectively, you realize there's a whole language called the Google Dorking, sort of Google Dorks. And so this is a language for telling, it's like an expression language that tells the search engine what you're interested in and what you're not interested in. And you can apply these are like regular expressions applied to your search. And so you can do things like do a multi-word search, like the string, put it in quotes. So a lot of people do that if you need the exact match of those 3 words consecutively. If you want to restrict the searches to particular file types like PDFs or particular extensions like TXT extensions, those are also Google Dorks. You could do site restricted searches. So if you do site:/pdx.edu, it restricts just to our website. You could say, I'm only looking for Twitter results in your search engine. You could restrict the searches for strings and URLs. So you're only interested in the admin string showing up in the URL, or titles, so HTML titles that have the security word in them. Or in the text itself, the payload itself, it says disallow. And then you're like, oh, I want to see what's disallowed. And you go and you get that file. So these are like common dorks that security people would do to basically find targets in search engines. Here's another one. You could do a negation operator. So if you don't want PDFs in your search, you can apply that. And then logical operators. If you're interested in both psychology or computer science and design, so design and psychology, design and computer science would be the sort of the terms, then you could produce that and send it into Google. So then the idea is like, okay, well, I don't want to learn that. But I want the LLM to produce the appropriate dorks from natural language. And I think this is basically what the Google Assistant is trying to do. Like when you ask the assistant to go search for something, it's probably going to go and do something like this to express it, get the search results, and then summarize it and stick it back to you. Okay, here's another useful one. If you've ever had to parse a JSON blob, you're like, oh, this is the worst thing. Because usually it's unstructured and you're like, you get this as an output and you're like, how do I get the information out of that? It's painful. And so here's an example that you're going to run. You're going to go to the certificate transparency log. So this is where when you talk about web security, you're going to basically issue yourself certificates to do TLS over HTTP. Well, the certificate transparency project is to, anytime a signer, a certificate authority signs a certificate, they publish this to this log. And then you can access this log, but like when you access the log, it's basically all this JSON stuff. But like if you want useful information about your certificate logs, you want to be able to parse this. And so before you would be like, well, I have to figure out how to write a program to, for example, get all the common names that are in the logs. well, then you would have to parse this thing and find the common names, and then across all of the JSON entries, go and find that to return the result. We want to do this without writing any code. And so there's this tool, JQ. It's a command that's a JSON parser. But like, we don't actually want to learn JQ. Like, I don't even know JQ. I just know JQ will parse JSON for me. And so like, okay, well then generate a JQ command that, given this snippet of JSON, pulls out, for example, all the common names, all the host names. So then the LLM is going to do the reverse engineering of the JSON blob, figure out how it's structured, the schema, and then it's going to produce the JQ command to get what you want out of that blob, and then give it back to you so you can execute it to get the information out of it. So that's number one. That's the first thing I'm going to have you do. And then you're like, well, why do I have to actually copy and paste that command out of the LLM? I'll just have the LLM just do the whole thing, which is another thing. This is what, like, if you did a notebook LM thing, you just say, here's the JSON blob, notebook LM, just find all the host names, which is another way you could do this. But you'll see that one is a little bit more cost effective than the other. If your JSON blob is megabytes long, then what you want to do is give the snippet so that you can actually generate the JQ command, rather than the poor LLM burn all the CPU energy or the GPU energy trying to do that itself. Maybe on the back end, the LLM is invoking the JQ tool. Sometimes that is actually happening underneath. But if you can avoid it, unless you actually know what's going on in the back end LLM, you should probably do the first approach. We're CS folks. We're like, yeah, just give the command. I'll run it. So that's the idea. And then you can actually compare the results. It used to be that this was basically awful, but I'm like looking at, so I'm running some of this stuff again, and like this is just as accurate as that is. And we'll see this in a couple weeks. There used to be something that the LLM was terrible at. It's actually just as good as doing it any other way. So yeah. IP tables. So this is a command in Linux to configure network traffic going to and from. It's basically a firewall system. And so it's got a complete language for configuring the rules that control the traffic going to and from your machine. So we use this in the, let's see, the intro to security class for network filtering. So then here's a rule. So if you've never seen IP tables, you're like, oh, what is this rule doing? So this rule, so if you don't know what this rule is doing, you just copy and paste it and say, into the LLM and say, tell me exactly what every piece of this command specifies to the IP tables runtime. So here it says on the input chain, on this interface, Ethernet 0, for all transport protocols that match TCP across all these ports, port 22, 80, and 443, which is the SSH port, the clear text HTTP, and the HTTPS. For any connection that's either a new connection, so a connection initiation, or has already been established, so you've already done the handshake, accept those packets. And then eventually you'll deny everything else. So this basically allows incoming 22, 80, and 443, as well as new connections on these ports, as well as established connections on these ports. And then the rest would be outgoing packets. So this is the input chain in IP tables. So you could ask the LLM, is like, what are the 5 different chains? What's the difference between the input chain and the output chain? And I'll explain it to you. So this is incoming packets, this is outgoing packets, and then you have to do the corresponding outgoing rule would be anything that's established, you accept with the source port of 22, 80, and 443, because every TCP connection is bidirectional. And so then you can use the LLM to help understand this. And then what you want to do is, so that's the first step. Have the LLM explain every bit of this. And then you ask the LLM for a prompt that would reproduce this. This is very similar to the lab last week, where you're like, here's some Python code. Give me the actual prompt that would allow you to reproduce this verbatim. So this is a pattern that you're going to do over and over again in your labs, so that you get really good at prompting, at specifying the prompt that will actually produce predictable results. So that's the next step. And then the prompt that it gives you If you copy and paste that back to the LLM and it doesn't give you exactly what you want, then you're gonna have to tweak it. You're gonna be like, well, I need to add some things that you didn't tell me to tell you. And that's what the last step would. And so the goal is to get a prompt that reproduces this verbatim for each one of these exercises. So that's IP tables. The next one is Google Cloud. So all of the courses that I run, it's using G Cloud commands to launch infrastructure and to configure rules. So here's one. It sets up firewall rules, creates this tag PDX80, and this allows incoming TCP packets. So this is ingress. So it's incoming TCP packets on port 80 from this network prefix, which is the Portland State Class B network. And then it says create a virtual machine called WFP1 VM of this machine type in this zone using this image, this virtual machine image that is hosted by PDXCS, which is my Google Cloud project. And then add this tag to that VM that you just created. So again, 3 commands that have to be exactly written like this to get what you want. And then you're going to say, well, first explain this to me. I just explained it to you, but see if the LLM also explains it to you in the same way. And then you ask the LLM for the prompt that reproduces it, and then you adapt it again for G Cloud. So the next one's Nginx. So those were commands. These are configurations. So here is a popular web server. And this is the web server I'm running on my desktop. It says your name, this for the server that's hosted, name mashimaro.cs.pdx.edu. I have all these server blocks for all the other machines that I host, but this is for this particular server name on this machine. This is the clear text, the clear HTTP port. This is where I want to serve the website from, the directory tree root. This is if I have a blank slash, this is the file that I want to return, the file index.html that's resident in that directory. And then on the root URL, you don't get indices. And then this is your error conditions. And then here's one that specifies, I want my content security policy, there should be a space here, to be this string. And so you're like, okay, well, what is all of this stuff? I didn't explain this content security policy string, but if you don't know what the content security policy is and you're not in my Web and Cloud Security class this quarter, you would have to have the LLM explain this content security policy string for you. And then you ask the LLM for a prompt that can regenerate all of this in natural language. And then you adapt it again to reproduce the configuration verbatim. So this actually helps you learn a little bit about the actual configuration. If you don't know content security policy, you're gonna get to learn about it, because now you're producing the, like in natural language, the function of what this header is actually implementing, which is actually kind of useful. Here's another one we do in the cloud class. So this is Terraform. So Terraform is an infrastructure as code configuration language. You specify the infrastructure you want to deploy in this Terraform file. It's declarative. It's got a different sets of blocks, like the provider. So if you're trying to do the Terraform deployment on Google Cloud, you'd say, this is Google, these are my credentials for deploying my infrastructure on Google. So you could fill this in with your own project ID. This is basically the name of your Google Cloud project, the region that you are wanting this deployment to take place in. And then you specify the resources that you want deployed. So I want a static IPv4 address, because when I bring up a virtual machine, I'm going to assign it to this thing. Here is the instance that I want you to create. This is the name, the machine type, the zone. This is the boot disk that is going to back this machine. And in this case, it's Ubuntu. So if you ever deployed a G Cloud, a virtual machine on Google Cloud, you get to select your operating system. And then in this case, if you use the default Ubuntu OS Cloud 2204, that's the image name. And then you can specify the network interface on this instance to be that static address that you defined here. And then you want the output value after the deployment. This is a very complex configuration. But this is something you have to be able to communicate to the model, or you're going to see if you can communicate this to a model in a way that you could regenerate this with natural language. Okay. Here's another one from the cloud class, a Docker file specification. You're basically configuring a virtual operating system image. You're specifying a base image, and then you're gonna run a bunch of commands to modify that base image to be a delta of that base, and then you're able to launch a whole bunch of these container images simultaneously on a single real operating system. So that's what this is. And in this case, this is a multi-stage build. This is one of the more complex Docker files. So this is what I want people to generate in the cloud class as their homework. So if you haven't taken the cloud class and you take it in the fall, I guess you have a leg up, because this is the Docker file that basically gets you the smallest Docker file. You're like, oh, I'm gonna define the base image to be Alpine, which is one of the tiniest images. And I'm going to have a builder container that basically installs all the packages, gets the requirements over, installs the package, the requirements from here, and then deletes all of the sort of the artifacts for installing the packages. Because like when you do a pip install, it downloads a whole bunch of this distro sort of information, and then you get the package out of there, but then that stuff is sitting there on disk. So you can remove it. Or what you do is you just take the packages that you need and you copy it from the builder container over to this runtime Docker container. So when you go and you ask the LLM to explain this to you, it's going to talk about this exactly, and then you'll learn how to you'll learn how a multi-stage Docker build works line by line. That's hopefully what you'll end up doing with this. And so you actually don't need this rm-rf, because like I'm not going to even use this container. It might actually tell you, well, that's redundant. You're not even, this is the builder, but then these packages aren't basically, well, actually, no, this is actually required, because it's just copying this directory over. Sorry, I misspoke. So you could ask the LLM, is there any more that I can do to shrink this container? And then you can come back to me and say, yeah, this isn't the smallest container you could ever build with this application. This is like the Python guestbook application that I have. And then you're like, okay, I'm just going to copy the artifacts directly and then run the thing. So again, have the LLM explain to you the specification of a multi-stage Docker build. So you learn something about Docker, and then ask the prompt, see how the LLM produces the prompt for itself, and then try adapting it to get this back. Okay, so another one from the cloud class, Kubernetes. Infrastructure as code done in a YAML file. So again, it's specifying deployments on basically your Kubernetes cluster. And so one of the things that it deploys is a bunch of replicas of your guestbook container. So here's the container right here. I have to specify these containers, and I have to specify 3 replicas of this container, and a replication controller that basically handles these 3 replicas and manages the 3 replicas to make sure that there's always 3 running. So if one fails, this replication controller brings another one up. And so then you can specify that, and then you need a load balancer to give you a single sort of front end to export your service. So you have a clustered back-end guestbook replica and the front-end load balancer that's basically routing the requests to each of the individual replicas. And that's what this thing is doing. So then you'll learn a little bit about Kubernetes specifications, because you'll have the LLM explain each one of these things and then ask for the prompt and then send it back and then adapt it. So I actually don't know how accurate. I don't know how much work this is going to be between this and this. It could be copy and paste, and it's like, yeah, verbatim gives it back to you. Actually, do this in a separate chat window, because it's really not fair to have the actual configuration in the chat. So yeah, do it in a different chat. Otherwise, the LLM's going to cheat. It's just like, oh, you gave it to me, dude. I'll just copy and paste it back. Yeah. So let's try and really organically get the LLM to do this in a separate chat window when you do these exercises. Okay. So the next lab, so that's like basically the first set of labs that you're doing. The second set of labs is basically command agents. I'm just going to have you interface with Linux using just the LLM. So this is like your terminal tool. So this is the MCP server for running commands. You get a string that the LLM produces, and then you basically do a subprocess on whatever command is given to you, and then you return the result. So that's your MCP tool that you're going to utilize. And then this is the agent. The agent you're going to parameterize. You're going to give it some instructions that narrow the commands that it generates. And this is better for the LLM because sometimes it doesn't necessarily know which commands are installed on a particular machine. Like different distros have different ways of accessing the packages, for example. And so in this particular agent, you say use these particular commands to do this particular operation. And that's the idea of sending the instructions as an argument to this client agent. And this is like super simple, right? It's like you're just using the command server and then just using the user's instructions. So these are all from, or most of these are from the Intro to Computer Security class. It's like, okay, PS, ls of are list processes and list the open files per process. And then ls/proc, you could do the same thing in the file system. And then we're also when we're talking about processes and startup processes, we're talking about cron tabs and cron.d, which are these scheduled processes and scheduled executions. And so then using this command agent, you could basically ask the LLM, just natural language interface to the shell, just say, find the names of all the processes with open network connections. And then it would do an ls of -i and then produce a summary of everyone who's got a connection on this machine. Show the path of the executable file used to launch SSHD. So if an adversary went in there and stopped the SSHD and ran a bogus malicious SSHD from a different directory, then this command would allow you to say, oh yeah, that's not the path to the SSHD binary. Show all processes where the original binaries have been deleted. So this is, if you take the malware reverse engineering class, this is very common. If the adversary doesn't want the malicious binary to be lying around for a file scanner to find, it'll basically download the binary, run it, and then delete the binary. And then the file system search is going to be like, there's nothing on here. Looks okay, but that code is running. But if you go into the sort of the proc/proc file system, you'll see that this is deleted. So if you run a command, for example, you can compile your own program that basically hangs, and you just run it, and then you delete the binary, and then you do a PS. This will show deleted. So that's another sysadmin thing that you could just use natural language to express. So then the idea is like, can the LLM generate these commands? Because the ground truth command that will actually produce what you're asking for. And then you can just see if the LLM can actually do it as well. Show the current working directory of the Python process. So then you have to do a PS to look for the Python process and then go into proc pid current working directory. There are multiple ways to do some of these things, but you can validate the result as being accurate. Here's another one. Show the environment variables of a particular process of the Python processes. So if you're an adversary, so this is why they're like, oh yeah, if you're running an agent like this, the adversary sees it. This is like, oh, this is money. I can just have the agent do all the malicious activity. So this would be one of them. You're like, okay, find the Python process of whatever's running, like maybe the agent, and then give me the environment variables. So go to proc pid environ, and then you can get all the API keys. Like, we stick all of our API keys in the environment. That's what you would do to get them all out and then use them for nefarious purposes. And then all processes which have the current working directory as /temp. This is also a malware trick. Like if it can't get write access to a user's working directory, language, And then this is another one. If you have a backdoor that you want to run, or a command that you want to run periodically, if the adversary wants persistence without having a process that lives all the time on that machine, you would use a scheduled task, maybe a periodic task. Then it wakes up, runs, and then goes away, so that sort of like integrity checkers will miss it unless they're actually scanning when this task is running, which is unlikely. Okay, here's another set of commands that we used to grind away to learn how to express using the CLI. So grep, text and regular expression file searching. And then WC is a simple word count one. That's not too hard to learn, but all the different regular expressions are kind of a pain in the neck. So the examples, and I'm just borrowing the examples from the Intro to Security class, there's this data dump of all the rocku.txt, rocku sort of compromised passwords. So rocku was a service that Yahoo bought, and it turns out this music service stored all of the users' passwords in plain text, and they got compromised, and it got dumped at basically public. So you got all the richest set of like plain text passwords at the time. This was like this was early 2000s. Yeah, this is a long time ago, but like people don't change their password patterns that much. So then you're like, okay, well, how many passwords begin with the letter A? And then you want the LLM to generate the regular expression hat A. And then how many passwords begin with the number 1? So hat 1. And so the hat means beginning of the string. And so that's why these are used. How many passwords consist of only alphabetic characters? And then it's going to use the beginning and the end. So the hat and the $. That's the beginning, that's the end. And then the square bracket says any character between little a and little z and capital A and capital Z. Give me any number, 0 or more, which is the plus. And then give me that string as a match against Rocky.txt. So part of this is not only do you want the LLM to explain this regular expression to you, you want it to produce that. And so this is the text that you're going to ask. You're going to prompt the LLM and with this, and then hopefully it's going to give you that. How many passwords are made up of exactly 6 numbers? So hat 0 through 9 is the character to match, and then the curly braces says this is the number of these matches, exactly this number, 0 to 9, 6 times. And then that should have had, I don't know if that needs $. Yeah, I don't. It doesn't need the $. Okay, you have a regular expression person here, which I'm not, which is good. List all passwords that begin with A, B, C, D, E and end in the number 9. That one needs $, because then .* is the wild card in the middle of the hat A, B, C, D, E. Okay. All right, the next one that's also got like some obscure syntax is the find command. So this recursively navigates the file system from the path that you're specifying to look for files of particular matching types. So here's one, find all set UID and set GID programs in /bin. So these are the privilege escalation ones that adversaries would target. So you're like, okay, I'm going to protect these binaries. Or if the adversary has planted a set UID or set GID binary in these directories, you want to see that they're there. Find all ELF executables in /bin. So then you can look and you do a file operation on these things and you search for the ELF file type. All files modified in the last day. So this is one of the examples in the Intro to Security class, because if someone has changed their configuration, you know you just got hacked and you're like, oh, well, what's changed in the last day? You can basically look in Etsy, and if the adversary has kind of like tampered with something in Etsy, it'll show up. Look for all the files created in the last day in Etsy. So the create time is this one. Find all SSH authorized keys in /home. So get regular files with the name SSH authorized keys would be the one in that case. And then here's one that will detect adversarial behavior. Find all history files and user directories that have size 0. So often if you have a compromised user account, The adversary is going to type a whole bunch of commands. It gets accumulated in a history file, and the adversary is like, I don't want you to see the commands that I ran, so I'm going to delete that file on my way out, and then it'll be null, and then you can see that in this find file. So again, these are all things that a sysadmin would do that you can now prompt with natural language. Okay, so more IP tables. So again, here's some just extending the commands. You can actually run these. I don't know why I put this here. Well, this is actually generating. Yeah, I don't know why. But so duplicate. I mean, I should consolidate this. These used to run on different weeks. IP tables. You can also use a configuration file to specify these rules. So here's one. Allows SSH traffic from this class C class D subnet. Okay, this is similar to the other ones. So I'll just move on. Audit logging. So if you want to figure out who has logged into your machine recently, you have, or who is currently logged in, who does the current logins, last B, and last log, does prior successful logins, prior unsuccessful logins, and then last log is similar to last. So find all currently logged in users, and then your command tool should hopefully run who. Find the last 5 successful logins. It uses last for those. The unsuccessful ones uses last B. The last 5 logins from the root user, and then you can specify the username and the number of logins that were recently performed, and that's your lab. The next one is network tracing. So, and then for this, you're going to have TCP dump. So TCP dump has a command language that allows you to specify filters of the kinds of traffic you're interested in. So again, those filters, we used to actually have to look up the language, but now we can actually have the LLM generate the language dynamically. So there's an agent that I have you run for capturing and analyzing traffic using TCP dump. And then you don't actually have to learn any of the TCP dump filter language, which is like hours and hours that I spent that I don't need anymore. So what I do is like, this one, so this particular one captures traffic, and then what we want you to do is have the agent analyze the traffic to figure out, tell me what's going on. And then we want to see how good the agent is. So rather than generating the filters, where you just dump all the traffic and then have the agent sort of interpret the packet trace and see how well it interprets the packet trace. So you're going to run this agent, and then you're going to run this command dig www.pdx.edu, and then hopefully the agent says you're accessing port 53 is the idea. And then the same thing with this. What is the destination of the last web request? You set up the agent, it's going to start listening, and then you do a curl to oregonctf.org, and it should come back with this answer. And then what addresses are communicating over SSH? So on your virtual machine, you can SSH to Linux, and then it'll have the 2 endpoints from the virtual machine to linux.cs.pdx.edu in this case. Okay. The next one, or the last one, we're going to have you do command generation to find any of the vulnerable packages you might have running locally on your virtual machine. So this is super useful. Typically, what you would do as a system administrator, you would do a systemctl to figure out all the running services. You do a dpackage query to figure out the packages they got installed from. And then you would do an apt change log on the package to see the latest release notes of that particular package. And then you ask the LLM, based on the current version that's running and the release notes of the last version, the sort of the up-to-date version and everything in between, is my package vulnerable? This is a very simple audit. Like, I haven't done an app upgrade, like on your Kali VM, I haven't done an app upgrade in like 6 months. And I bet you there are some out-of-date packages there that have vulnerabilities in them. Well, this is what you can do. You can have the command agent tell you this by directly having it, well, hopefully it can produce the commands with these, it can produce the commands using these tools to be able to answer those questions. So that's your exercise. There's multiple. You could do this with prepackaged tools where you guide the LLM So there's two versions of this. There's one where we actually give you tools that know a little bit about what these things do. And then we say, okay, the LLM can then use these tools. The other way to do it is to just give LLM full autonomy, is to just say, I think you know enough about these commands to just do it directly. And then you're going to compare the outputs. Because really, that's what's going on right now. Sometimes you can have the LLM do everything, and sometimes you need the specific tools to guide its execution. That's why I have this one done two ways. And I think hopefully they're accurate. They're the same. If they are the same, then maybe I can delete one of them. Okay, so the homework is build something where you can just talk to your machines and talk to your deployments or actually launch deployments. So you're going to have something where you can say on your GitHub, it's like, I have this program that does agentic infrastructure deployment. That sounds super cool, but it's like, it's reachable. Like that's what you're building this week. So for you to put that on your resume is probably a pretty good thing. So you're just going to use these LLM generated commands and configurations, and you're going to build agents to actually like run them. And then that's kind of scary, but like that's what the new hotness is. And eventually, hopefully the LLM is going to be accurate enough. I don't know. It's hopefully going to be accurate enough that you'll trust that deployment with natural language. But then you'll see where it goes wrong, and it'll go wrong when you don't prompt it correctly. And then you'll have that understanding to be able, and you could build tools so the one nice thing about MCP tools is that it puts guardrails on the LLM so it doesn't go too crazy. Like this one, it's like, oh, if you allow the LLM to arbitrarily run different versions of this, it could go crazy. So this is why the MCP tool kind of like focuses what the LLM can launch. And so that would be something that you're probably going to have to deal with when you build these MCP servers or agents to do these things for yourself. Yeah, use of MCP is encouraged. Building your own MCP server to do some of these things, or utilizing off-the-shelf MCP servers. So if Docker's got an MCP server that you want to sort of leverage rather than writing your own Docker, that's perfectly fine. And then you could I don't think Google Cloud has an MCP server for their G-Cloud commands, but if they do, you could do that as well. And then just have your app just talk yeah, it could be you launching MCP servers of all of these infrastructure configuration things that are out there. I haven't checked the list yet. And then your agent is like, whatever, 10 lines of code. And then you can actually just run you still have to establish the credentials for doing the deployment, but then it's just basically talking to the MCP servers that will actually do the hard work, is the homework. Okay, so that's it. The rest of the time, you can just get started on the labs. Are there any questions? Oh, there's a sign-in sheet, though. So let me pass the sign-in sheet around, and I'll let you all get working.